Hi guys, and welcome to this session. Today we will discuss the most basic and fundamental law of electronics, that is called Ohm's law. Before proceeding to this video, first of all we will discuss some key concepts which will help us later in the coming video. We will not go into the detail of these concepts because most of you have better understanding and knowledge of these terms. We will just memorize these terms to refresh your knowledge. For example, current. It's very basic quantity. We define it as the time rate of change of electric charge is called electric current. Mean electric charge in motion in given time. Both magnitude and direction is associated with it. Current is measured in amperes and it is symbolized by the letter I. This is the mathematical relation or mathematical equation defines the whole phenomena. What it is? I is equal to delta Q over delta T. Here delta Q is the amount of charge in 1 second. We can further explain it as if 1 coulomb of charge passes in 1 second from one point to another, then it is called 1 ampere of current has passed. 1 coulomb of charge means 6.24 into 10 raised power 18 electrons. Now voltage. The voltage or potential difference across the element is the work required to move a positive charge of 1 coulomb from one terminal to the other terminal. Voltage are measured in volts and symbolized by the letter E or V. Next, resistance. It is basically opposition to the flow of charge. Resistance is measured in ohms, symbolized by the letter R. It is some kind of hindrance which is basically tends to stop the flow of charge. Now we will go into the details of this law. First of all, we have a brief introduction. It defines the relationship between the three basic concepts: voltage, current and resistance in an ideal conductor, established in the late 1820s by George Simeon Ohm. That is, the voltage across a resistor is directly proportional to the current moving through that resistor. So mathematically we can write it as V is directly proportional to the I in a given time domain. So may explain it as we have an ideal conductor whose resistance is R. If I passes through that resistor or that conductor, then it drops the voltage Vt across the resistor. The upper relationship may write as V is equal to Ri. Here R is called the proportionality constant of resistance. We can explain this concept graphically by putting the values of current on x-axis and values of voltages on y-axis, and we get a straight line by intersecting the points of resistance by different values of voltages and current. The material which obeys Ohm's law is called ohmic or linear because theoretically the potential difference V across it varies linearly with the current. Here we will prove this concept with the help of this example circuit which contains the DC source of 5 volt and 3 resistors R1, R2 and R3 in series. We make the circuit in such a way that we have the fixed voltage source of 5 volt and we will vary the values of resistance with the help of these switches S1, S2 and S3 for different values of currents. And there are two objectives of this circuit which we will attain at the end of this simulation. Number one is to verify that voltage and current are directly proportional to each other by varying the resistance. And number two is to verify the law for resistors in series circuit, which states that the total resistance of the series circuit is equal to the sum of all individual resistors in series circuit. Let's start the simulation. Here we have the same circuit. We will record the three different values of currents for three different values of resistance and compare it with the voltage source. Let's start the simulation. Initially all switches are open. In the first scenario we will close the switch A and the other two switches will remain open. Here we can see the amount of current drawn by the circuit is 5 mA and the path of current should be like as shown by these red arrows. The only 1 kilo ohm resistor R1 is in the way of this circuit. We see the product of R and I is equal to the source voltage. Now in the second scenario we will close the switch B and switch A and C should remain open. In this case the path of current is shown by these red arrows. So we see two 1 kilo ohm resistors R1 and R2 are in the way of this circuit and the amount of current run by this circuit is 2.5 milliampere. And similar to the first case, the product of current and two resistors R1 and R2 is equal to the source voltage. And now in the last case we will close the switch S2. Now the current will pass through all of these three resistors because the other two switches are open and the path of current is shown by the help of these red arrows. Now the product of current and three resistors R1, R2 and R3 is equal to the source voltage. Hence, with the help of this simulation, it is proved that the product of resistance and current is always equal to the source voltage. Thanks for watching this video.